Many of the equations that we see in this course will have two variables, usually x and y. Sometimes you have p and q, whatever those variables are, but we typically have two variables. Later in the course, we'll see equations that have more variables, but in general, there are always two variables in an equation, and the equation expresses the relationship between the two quantities, between the two variables. For example, like if we're talking about a profit function, so for a number of items that you produce, a company produces, then there is a profit, or there is a cost, or there is revenue, right? So x could be the number of units produced, and then the y variable would be the profit of producing that number of units. So there are many examples like that. So an equation expresses the relationship between these two quantities. There is a special type of relation called function. A function is, when you write the function, it is an equation basically, but it's a special type of relation. And one of the best ways to exemplify that is by giving you a couple of examples. So let's say we have remember the two variables. So let's say one variable here and then the other here. And let me make a list of possible values. For example, let's say that the values for x would be 2. And then let's see, let me pick a few numbers here. 5, 7. And then here we have a bunch of numbers for y. So we could have 10, 2, and many more. So I'm just listing 3 here for x and 2 here for y. And then for the value of x equals 2, then let's say the value would be for y would be 10. So those two numbers are related. It could be from something like if you produce 2 units of a certain product, then your revenue would be $10,000 or $10 million, whatever it is. Then if you produce 5, or if the number 5 is related to number 2 for some reason, and then the number 7 is also related to number 10. Okay, that could happen in some situations. Not necessarily with the number of units and revenue, but a relationship between the two variables. So this is a function. What describes really a function is that for every value of x, you can only have one value of y. So for example, the number 2, there's only one value of x for the x equals number 2. There's only one value for y, which is 10. For x equals 7, there's only one value of y, which is y equals 10. Although the value for x equals 2 and x equals 7, the y value is the same, but for every value of x, you only have one. What cannot happen is a situation like this. So let me give you another one. Is when you have, for example, let's say you have a number 2, and that is related to number 10, and then number 2 is related to number 8. That situation cannot happen. If this happens, if you see something like this, then this is not a function. Okay. So you can think about a value of x having two values of y, and that is on a graph or any situation, then that is not a function. Because of this idea, then we can view functions as sort of like input-output machines. So here is a function. And when you put a value here in a function, value 2, for example, and the function will process that value and it will give us something. Let's say it gives us number 10. Okay. And if you throw different value here, let's say throw a number 7, you could also get a number 10, and that's fine. Okay. But what cannot happen is that when you throw the number 2 again, then you have a different value. If you have a different value, right? If that happens, you put a number 2. If for the number 2 you give 2 different values, that cannot happen. So this situation here would not happen. Otherwise, it would not be a function. Okay. It's like putting ingredients when you make a cake, right? You're putting the same ingredients, the same process, and you get the same output. It would not make sense if you put the very same ingredients, same process, and you get something else. So if that happens, then it's not a function. So we can describe a function as an input-output machine, and we're going to give a name to this function. We can call it function f. Sometimes it would be g, or could be all kinds of letters, h. So this function, the name of the function is f. So because of this, there is a mathematical notation. Math notation. Math notation means that it's a way that we can write. It's a with mathematical symbols to represent this idea of function. And the idea is that we have f of x. So f of x, and this will give us the y. Okay. So you may be confused. What is this? What do we do with the f with x? It's just a notation. It means that this guy here, this x, is the input, and the y is the output. So you put x inside the function f, so that's why you have the parenthesis. You put x in there, and f will process that x, and it will give you y. Now let's look at a more practical example to see how this works. So let me give you an example here. Let's say I have this function. It's 3x minus 2. Some of you may already be familiar with that. But that's the function. So let's say the function is that. What does it mean? Well, it means that if x is, let's say, 2, what will be the y? What will be the output? If x is the input, what will be the output? Well, you can find the output by plugging the 2, which is the input, right? You plug that into f. So you take x equals 2 and you put it right here inside the function f. Okay. So again, this is not f times x. It's a notation. It's a symbol. So we put x inside the function, and the function will give us what? Well, we just look at the formula for the function. It will take x. The function will take the input and multiply by 3 and subtract 2. So take the input, multiply by 3, and subtract 2. So 3 times 2, 6, minus 2, 4. So that means y is 4. Okay, it's a way to describe the output by using this notation. So in other words, you have the input here. When you have the input into the function, then the function will process that by multiplying 3 times the input minus 2. Right? So that's what the function is doing. Now in practice, to make it easier for us, every time you see this guy here, f of x, you can just treat it as the y. Okay? So in other words, this can be also written as y equals to 3x minus 2. So that's the simplification. But behind the scenes, right, so the concept is that this should be a function. for every value of x, you only have one value of y. All right, let's take a look at this example here. It says determine which equations specify functions with independent variable x. The variable x, we usually say that it's independent because it doesn't depend on anything. But the y variable, usually we call it dependent because the y is the output, right? So the output always depends on the input. So that's why we call x as independent variable, and the y we call it dependent variable. All right, let's take a look at these equations and see which ones are functions, which ones are not function. Now, the best way to do this, you remember that we can treat every time you see the f of x, you can treat this as y. Okay, so in order to see if it's a function, we need to isolate the y so we can see what the expression, what the formula is, and see if it's a function or not. So the first step is to isolate. So we isolate y. Okay. So let's do that. If I look at this equation, I'm going to move the 4x here. I move it to the other side of the equation, so it will become negative 4x. And then divide both sides by 2, and this will become y, right? They cancel here, and then there's two things being subtracted, which means when you divide each one of them. So 8 divided by 2 is 4, minus, and then 4 divided by 2 is 2. So that is the formula with the y isolated. Now, is this a function? Well, if you remember what this is a linear equation, right? There is a slope. Here's the slope, negative 2. This guy here is the y-intercept. Okay? And we can draw this. So we can draw, and so the y-intercept is 4, and the slope is negative 2, so this is a line that goes down. So it goes down like that, okay? And it's a straight line. So this is a function because if you notice, for any value of x, right? So for here you pick a value of x, and there is only one value of y here. There are not two. So the best way to what we can conclude in here is that you are able to isolate the y, and whatever you plug in here for x, you have one value. You don't have two, right? If x is 1, you get 4 minus 2, which is 2, so it's only one value. Okay, so it is a function. Let's take a look at the other one. This one here, let me write down here. This is x. This is x plus y squared equals 9. Okay. Well, let's try to isolate the y. So here's y squared, 9 minus x, right? Okay, subtract x. And when you have something squared equals an expression, you can take the square root. Okay, so you take the square root of both sides. The problem is when you take the square root, you get a positive and you get a negative version of it. So I'll give an example. Let's say if you have something like if I have a equals 9, okay, and well, instead of using a, let me use y squared. Maybe same example here. This is not the same as this one. This is just an example here. Then you take the square root of 9 and you put a plus or minus 3. Plus or minus 3 here is the solution. So this means that 3 works here, right? If you put 3 in for y, so 3 squared is 9. But if you put -3, you also get 9. So there are two versions of that, two solutions for that, two numbers. Okay. So that's when you take the square root. So that means this is not a function, because whatever x you plug in here, you're going to have two values for y. For example, if you plug x equals 0, right? If x equals 0, then the y would be plus or minus square root of 9. This is plus or minus 3, right? Here's another example. If x is 5, then this would be y equals plus or minus square root of 9 minus 5, right? Because I'm plugging x equals 5 here. And this would be plus or minus 9 minus 5 is 4. And this would be plus or minus 2. You see, for the value of x, I got two different values of y. So this is not a function. So this is not a function. Yeah. There is one way, if you see a graph of an equation, graph of an equation, there is actually an easy way to find out if the graph is a function or not. It's called a vertical line test. So if you have something like this, right? So this is, let's say this is the graph of an equation. And if you draw a vertical line like that, and if the vertical line crosses the graph in more than one point, then the graph is not a function. Why is that? Well, that's because for this value of x here, whatever this value of x is in here, notice that it's relating to this value of y, and it's also another value of y, and it's another value of y. So for this value of x, you have three values of y, and you cannot have that in a function. Okay. So that's called this is called a vertical line test. All right.